What's going on in here today?
We're having a science fair for 4th through 6th grade. They had the option of working with a partner, or if they wanted to qualify for the county 4-H science fair, they could work by themselves. We will be judging and we will be picking one in each grade level for the categories of life science, physical science, and earth science. And if they place, they will get to go Monday, May 16th, to go against other students in the county.
What's your name?
Ethan Elder.
6th grade?
Yes, sir.
Tell me about this.
Okay, so what I'm doing here is direct current. You'll take a little clip where you'll hook on the lock switch, and then you'll take another one, do the same thing. Then you have your light come on. But for your negative, you'll take the gator clip again, and then you'll hook it, take it down the wire, and then it'll hook right under the screw, and then you'll have your circuit.
Is this your partner?
No, he's got his own little simple circuit over there.
I'm just being really mean to him. He's my friend, and we can be mean to each other. So.
What's your name?
Harmony Hearts.
And you have made a giant chocolate kiss.
No, a volcano.
Volcano. Okay.
Yes.
What's it going to do?
Well, it's supposed to erupt, but at my school we're not allowed to erupt it. And I made it out of Play-Doh and spray paint.
So they won't let you let this thing erupt?
No, or I'll get in trouble for it.
What's your name?
Trevor Smith.
Is this your lunch?
Yes, sir.
What is this?
You take your soda, you dump it over the apple. You plug your phone charger into the side of the apple, you plug it up into your phone, and it charges your phone.
Are you serious? You pour Sundrop over that apple, and you can plug your phone into it, and it'll charge your phone. What's your name?
Carson Litchell.
And
Caitlin Litchell.
what have you got here? What is this?
The smaller one goes faster, and the big marble, it'll go slower because it's got more weight, and it will take longer.
So how's this like a satellite? What's this show?
Satellites, they go around the Earth without going off into space. They stay around Earth's orbit.
What's your name?
Crystal.
Tell me about this.
Our question was, how can we tell which direction the wind is coming from? And our hypothesis is that we can tell where it's coming from by using a wind vane. So I'm blowing from the east. It usually takes a stronger wind sometimes.
You don't have enough wind in you, do you? You making pancakes?
I'm making things explode.
It's gonna make things explode. So you're putting baking soda into the balloon.
Yes.
Just baking soda.
Yes.
Arm & Hammer baking soda.
I don't think it really matters what baking soda,
Okay.
but
And then you put it on the bottle, which has just, what's in that bottle?
vinegar.
Vinegar. Making things sink, then float by Hunter Stewart.
Well,
Show me.
the clay before you make it to the boat, it's a clay ball and it sinks.
Okay.
And so the marbles.
But then you make a boat out of it.
When you make the boat, it increases surface area, which it increases surface tension on the water. So it floats.
Wow. So what are you demonstrating here? Air pressure? Or
How to get air out of marshmallows. Not really air out of marshmallows, if they can see.
how to get air out of marshmallows? Why do you have a normal marshmallow and a squish marshmallow? What are you showing here?
The squish marshmallow has no air inside of it, and the normal marshmallow has air inside of it, and the normal one can't sink, but the squish one can.
And then you've got one in water.
Yeah, it's sunk. There's no air inside that one. The Just the air.
Marshmallow. No, if it's not squished, then it'll float. If it is squished, then it'll sink.
Oh. That's-
Because the air inside the marshmallow is more dense and less dense than the water, so it doesn't sink.
Okay.
Are you done?
You can come back here and we gotta get more milk and redo it all if you want to.
So that's milk in there,
Milk
It-
and
and you ran out of milk.
That's what we're going to do. We're going to get somewhere.
They are just so.
Oh, please, no.
Why did you not bring enough milk?
We did bring enough milk.
Should have brought a cow and just left them outside. You just went out there and. What's it supposed to do?
Well, it's supposed to mix and it's supposed to be tied up.
Can I try?
You want to try it? Here, we can do
They had
it.
a word for that back in the 60s. It was called groovy.
Just wait just a minute, okay?
You still say groovy today? No?
Ready? Come over here. Come over here. Alright.
Yes, absolutely groovy. Which candle burns the fastest? What's your name?
Ashlyn. Mercedes.
And how can you tell which candle is going to burn the fastest by just looking at them like this?
Because they all have like different amounts in them.
So which one burns fastest?
They're in order.
Because it's got less wax.
Yeah. You want some popcorn?
Are you just running a concession stand or what?
No. Here, I'll explain everything to you. Okay, I did my project over which brand of popcorn would pop the most kernels, and leave the least amount of unpopped kernels. What you have to do in this project, you have to buy 4 different brands of popcorn, and then you pop the first brand in the microwave for 3 minutes. Then you put the leftover unpopped kernels and place each kernel in a plastic bag. Then you repeat steps 2 to 3 with the other 3 brands of popcorn, or however many brands you have. Then you count the unpopped kernels in each bag and add the total number of kernels for each brand. My hypothesis was that Orville Redenbacher's, which is this one right here, will leave the least amount of kernels. But my hypothesis is wrong. Really, Pop Weaver extra buttered popcorn left 7 kernels and left the least amount of kernels, and Pop Secret buttered popcorn left 15 kernels, so it was sort of in last place. And Orville Redenbacher's was in 3rd place, so my hypothesis was definitely wrong.
So you recommend Pop Weaver
Yes, I do.
for Orville.
Well, my zipper circuit has sorts of different types of materials you can have for the circuit to make it. You have to take your wires, take your red one, which is your positive, and put it in a positive terminal. Take the black one, which is your negative, take it to the negative terminal. Then you have to hook up the flashlight, take the battery, zip tie it in, zip tie the flashlight, the light into it, and then you have to put your switch on, and finally you just have to make sure it works, which it does. And if you want to know some more detailed instructions, this right here is my instructions for building a simple circuit.
So this wasn't a part of your original experiment.
No.
So do it again. Wow. Is this what caused that mess in the floor a while ago?
Kind of.
What's your name?
Ashley Grayson.
Tell me what you're doing here.
Okay.
Are you making galaxies?
No.
Making stars? Making stars?
Here.
Whose jacket's up here?
Hers.
Why?
I'm going to put mine up there because we have to have it really dark to do this.
You gotta keep the stars warm, right?
Yeah. Or they won't blow up. We're looking at the star, but it's looking like it's in the water. And it makes it look more... Sorry.
Hoverboard.
Somewhat. Faggots.
Show me how you do this. What is this?
It's supposed to be a hoverboard. Since the magnets are on the same pole, they'll repel. If they're the same thing, they'll attract.
So demonstrate.
The magnets here are all facing north. So if you look at the clear plastic, you will see it hovering right now. So I prefer using strong strip magnets, but the ones my dad bought weren't strong enough. So my dad bought 50 round magnets for like $3. You pull it slowly, it'll start hovering. Sometimes this will happen because of the gas in between them.
Yes, this looks interesting. What's your name?
Logan Green.
All right, Logan, what have you got?
I have 4 batteries here, and I've figured out that the thinner the wire is on that you hook to the batteries, the better it's going to pass through. And the more batteries you use, the brighter it's going to be. I originally had a button on this, but it broke. I got it fried out, and so you just needed some batteries. You don't necessarily have to have 4. You can have AAA batteries, AA batteries, 9-volt batteries. You can do this with almost every battery that they have. You just have to have a lot of them if you want a smaller battery. So that's about all I've got right now.
Why are they so important?
What is it about cat whiskers?
The reason why they're so important is because if they don't have cat whiskers, they can't fit into any holes or halls.
So cats have to have whiskers. Or else what happens?
They won't fit into any holes.
They won't go into a hole if they don't have whiskers? Serious? How did you do your experiment? Did you get a cat? Don't tell me you got a cat until his whiskers off. What are you going to be when you grow up? A vet?
Yeah, or a nurse. Either
Or a nurse? You'll be a whisker technician. You like watching it do that, don't you?
Yeah, it's cool.
What's your name?
Kelly.
And you are?
Hannah.
Show me what you have. What are we trying to do? Show how to stay away from mosquitoes?
The bats are supposed to eat the mosquitoes. And, well, we have mosquito plants called the citronella plant. And it actually tries to make the mosquitoes go away. This candle is also called a citronella candle. If you light it, it will actually make the mosquitoes go away because it attracts the smell and it will not let them stay close. And this is supposed to be a zapper where mosquitoes, they get zapped and they would be killed.
Did you keep up with all that? What are you doing here? Cleaning pennies?
No, I'm doing like what affects surface tension. And,
Surface tension, what is that?
well, it's how much water an object can hold on an object. So I took tap water and soapy water, and counted the drops onto a penny to see which one can hold the most. My results show that soapy water doesn't hold together as well as regular water because regular water has nothing in it, like soap does. So that's it.
They're your pennies.
Yeah, they're my
Where'd a girl like you get all that cash? What's stabilized whipped cream?
It is whipped cream. That has gelatin in it, which makes it thicker. Once you do the gelatin, you have a stick shape that will like stick. And this is like what they put on cakes, whipped cream.
So it's good.
And if you don't have gelatin, this is what it looks like.
Very liquid.
Watery.
Is this stuff they learned in class?
Yes, a lot of it is, and we actually spent all this last week working on the projects.
Is there anything liable to blow up in here?
Not supposed to be, but you never know.